Good morning. Welcome back to my channel. My name is John Vincent S. Saracanlao, and this channel is about research and research statistics. Our topic for today is about mean and standard deviation. Mean and standard deviation are basic in research statistics because we want to know the mean of the responses and there's the mean of the scores. However, mean goes hand in hand with standard deviation. I will explain further later how so. But first, let's define mean. Mean is the sum of values in a distribution divided by a number of values. It is one of the most common measures in central tendency. Basically, that's a mathematical definition, but basically, its mean simply means the average response or score. Next, you have standard deviation. The standard deviation is the square root of the quotient obtained by dividing the sum of squares of deviations of the observations from their means by one less than the number of observation in the sample. Again, that is the mathematical definition. Actually, it's the formula in words. In simple terms, standard deviation shows the extent of the distribution of the responses. Here we have different examples. I'll have different samples on mean and standard deviation, but first I'll teach you how to get the mean and standard deviation using Microsoft Excel. So it's very simple. You just click equals, then average, open parentheses, highlight the score responses or scores you want to get the average, then enter. For standard deviation, just type equals stdev, open parentheses, then highlight the scores or responses. Choose to copy the scores. Go to copy. To get the others, you just Control C, then Control B, then you will have the average and standard deviation for other response. Look at the scores. In the first section, we have 10 students here. It scores with a highest score of 10. Let's say they got a 10 item quiz. So the section number 1 here, we have 5 students who got the score of 1 and 10 students who got the score of 5 students who got the score of 10. And the average is 5.5. Section 2, we have all students who got the score of 5 and average of 5 and the standard deviation of 0.00. In section 3, they have the scores 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and the average is 5.5, the standard deviation 3.03. Section 4, we have 3 who got 4 who got 5, then 3 who got 6, basically the saturation of score in the median. And on section 5, we have 5 students who got 6 and 5 students who got 5, indicating scores just above the median, half the scores just above the median. As you can see, most of the average falls under to 5.5 to 5.5. However, the standard deviation varies, and that is very important because mean and standard deviation goes hand in hand together. Take for example section number 1. We have 5.5. That's the average scores of the students. However, the standard deviation indicates 4.74. This means that we'll look at this graph, this table. This will show you what it means, the score, the standard deviation. For example, if the score is 0.01, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, then 0.8, then 0.9, then going above, it has implications. For example, it's 0.1 is very similar, 0.2 is very similar, 0.3 similar, 4 similar, 5 still similar, 6 still similar, 0.7 starting to varies. Then 8 is varies, then 9 varies a lot, 1 varies a lot. This means that 4.7 basically tells you that the mean, the standard deviation indicates that it varies a lot from each other. Even though the average is 5.5, the scores of the students varies a lot from each other. And here, you have here, section 2, they all got the score of 5. And that means they have similar, or actually the same responses. And we have section 3, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The average is 5.5. And the standard deviation varies a lot from each other. We have here. So, as you can see, the standard deviation goes hand in hand with the mean. Simply because when the standard deviation indicates the closeness, the sameness, and the variation of the scores. Let's bring that to another venue. Let's say the responses of the students is, let's say, very positive to your innovation. However, the average is very positive. However, we have to consider the standard deviation. Is it the same? Are their responses the same, or does it vary? Do they all like your innovation, or the distribution varies? And from that, you can really make implications and have strong conclusions. For example, when you have the scores of 7 out of 10, and that's the average score, and in a class, then you have a standard deviation of 0.01. That basically indicates that you can safely conclude that those students are scores are above average. Categorically, you can consider them as brilliant one. However, if the standard deviation varies a lot, like for example section 1, we cannot say or conclude that the students in section 1 are average, because as you can see, there are 5 students who are very good, actually outstanding. They got a score of 10 over 10, but also 5 students who got the score of 1. So is it fair to say that the section is average? No, the standard deviation does not indicate that, because the score varies. So I hope that this video will give you a certain degree of enlightenment in the importance of mean and standard deviation. So thank you. Please like and subscribe this channel. Bye.